What if I told you that right now, as you breathe and blink and exist, you are trapped inside an invisible bubble that you can never escape, no matter how much technology advances, no matter how many millions of years humanity survives, no matter how fast we can travel through the cosmos? What if this is not a conspiracy theory or cheap science fiction, but rather an inevitable conclusion of modern physics that Neil deGrasse Tyson himself, one of the most respected astrophysicists on the planet, has publicly admitted with a mixture of fascination and scientific melancholy? We are all trapped and never realize why this prison is so vast, so absurdly gigantic, that it gives us the illusion of infinite cosmic freedom. But the naked truth revealed by the equations of general relativity and the observations of the most powerful telescopes ever built by humanity is that there is a fundamental and insurmountable barrier all around us, a boundary beyond which the universe simply ceases to exist for us in any meaningful way. And the most disturbing thing of all is that this boundary is shrinking with each passing second, making it our prison. Progressively smaller cosmic galaxy, trapping us ever more in a region of space-time from which billions and billions of galaxies are disappearing forever from our reach. Like ships sinking silently beyond a horizon we can never cross. Neil deGrasse Tyson explained this in a way that made even seasoned scientists feel an existential chill run down their spines, because when you truly understand the implications of this discovery, when you truly grasp what it means to be trapped in this way, your perception of our place in the cosmos changes radically, and you never look at the night sky the same way again. But before you think this is about some kind of physical dome or material barrier around the Earth, let me be absolutely clear. What imprisons us is something infinitely stranger, more fundamental, and more inescapable than any concrete wall or science fiction force field could be, because our prison is built from the very fabric of space-time, forged by the most basic laws that govern reality, and engineered by the accelerating expansion of the universe that is literally tearing the cosmos to shreds around us. And if you're one of those who love to unravel the deepest mysteries of the universe, who feel those butterflies in their stomach when they discover that reality is even stranger than any fiction could imagine. So subscribe to the channel right now, because what I'm going to reveal in the next few dozen minutes will completely explode your understanding of what it means to exist in this universe, and I guarantee that you'll want to be here for every new cosmic revelation we share. The story of this discovery begins in a seemingly innocent way, with one of the oldest and most fundamental questions that humanity has ever asked. A question so simple that even a child can ask it, but so profound that it took decades of work by the greatest geniuses in physics to begin to answer adequately. And that question is simply, how big is the universe? For most of human history, we thought the universe was relatively small. The ancient Greeks imagined a celestial sphere with a few thousand stars fixed to it at a distance of perhaps a few million kilometers. In the Middle Ages, many believed that the entire cosmos could fit into a region not much larger than our solar system. Even when Galileo pointed his telescope at the sky in 1609 and saw that the Milky Way was made up of countless individual stars, we still had no idea of the true scale of the universe. The first great expansion of our understanding came in the early 20th century, when an extraordinary woman named Henrietta Swan Leavitt discovered a crucial relationship between the brightness and the pulsation period of certain variable stars called Cepheids. This discovery may seem technical and dry to outsiders, but it was absolutely revolutionary because for the first time in human history, we had a cosmic ruler, a way of measuring true distances in the deep universe. And when Edwin Hubble used that ruler to measure the distance to some spiral nebulae in 1923, he made a discovery that shocked the entire astronomical community. These nebulae were not small clouds of gas within our galaxy, as many thought, but rather entire galaxies, True cities of hundreds of billions of stars located millions of light years away from the Milky Way. Suddenly, the known universe had expanded by a factor of millions. What we once thought to be the entire cosmos turned out to be just our own. The local galactic neighborhood, and beyond it, were billions and billions of other galaxies spread out over distances so vast that the human mind can barely begin to comprehend them. But that was just the first of many disturbing revelations to come. Just a few years later, in 1929, Hubble made another even stranger and more profound discovery. He noticed that when he analyzed the light coming from distant galaxies, it was systematically red-shifted, that is, to longer wavelengths, and the further away the galaxy, the greater this shift. At first, this may seem like just a technical curiosity, but the implications were absolutely revolutionary, because according to the Doppler effect, this redshift meant that these galaxies were moving away from us. And not only that, they were moving away faster the further away they were, which meant something truly extraordinary and counterintuitive. The space between the galaxies itself was expanding. The universe was not static, as practically everyone believed, including Albert Einstein himself, who had reluctantly added an artificial cosmological constant to his equations specifically to keep the universe static. But now, Hubble's observations showed unequivocally that the universe was expanding, continually growing, stretching like a balloon being inflated. And the universe is expanding now. This means that in the past it was smaller, denser, hotter. And if you rewind that expansion to the beginning, you inevitably reach a point where the entire observable universe was compressed into an infinitesimally small, incredibly hot and dense volume, what we now call the Big Bang. The birth of space-time itself approximately 13.8 billion years ago. Now, you might be thinking, if the universe has been expanding since the Big Bang, that doesn't mean it's infinite, or at least incredibly vast, so how can we be trapped in a bubble? And here's where the story gets truly fascinating and disturbing, because the expansion of the universe, combined with the finite speed of light, creates an inevitable and deeply strange consequence that defines the absolute limits of what we can know, achieve, or even see in the cosmos. Let's start with a fundamental fact of physics that Einstein established in 1955 with his theory of special relativity. Nothing can travel faster than light in a vacuum, which moves at approximately 300,000 kilometers per second. This is not just a technological limitation that we will someday be able to overcome with more advanced engineering. It is a fundamental law of nature, an intrinsic feature of the structure of space-time itself. And as Tyson often emphasizes in his lectures, this limitation has profound consequences for what we can know about the universe. Now combine this finite speed of light with the fact that the universe has a finite age of approximately 13.8 billion years. This means that the most distant light we can possibly detect comes from objects that were at most 13.8 billion light-years away when they emitted that light, right? Well, not exactly, and here's where things start to get really weird, because space was expanding all this time as light traveled to us, so the most distant objects we can see today are actually much further away now than they were when they emitted the light we're detecting. By doing some calculations using general relativity and the observed parameters of cosmic expansion, cosmologists have determined that the region of space from which light has had time to reach us since the Big Bang, what we technically call the universe observable, has a radius of approximately 46.5 billion light-years. This means that we live at the center of a sphere this astronomical in size, and everything beyond that distance is fundamentally beyond our observational reach. At least for now, light from objects beyond that boundary simply hasn't had time to reach us since the birth of the universe. But here's the truly crucial part that Tyson always emphasizes when talking about this topic, and that most people don't immediately realize, If the universe were expanding at a rate constant or slowing down, then our observable sphere would be continually growing. Each passing day, a little more light from previously invisible regions would reach us. Each year, more galaxies would enter our observational horizon. And given enough time, eventually we could in principle observe the entire universe, be it finite or infinite. But that's not what's happening. And here we get to the heart of the disturbing thing about this cosmic prison is because in 1998, two independent teams of astronomers, led by Saul Perlmutter, Brian Schmidt, and Adam Rees, made a discovery so shocking that they initially thought they had made a mistake in their calculations. They were studying type Ia supernovae, exploding stars that are so consistent in their maximum brightness that they serve as cosmic standard candles, allowing us to measure distances with extraordinary precision in the deep universe. And when they plotted the relationship between the distance of these supernovae and their redshift, they expected to see evidence that the expansion of the universe was slowing down due to the gravitational pull of all the matter and energy it contains. But what they found was exactly the opposite. The expansion was not slowing down, it was accelerating. The universe is not only expanding, but it is expanding faster and faster with each passing moment, as if some mysterious force is pushing all the galaxies away from each other with increasing intensity. This discovery was so important and so profoundly disruptive to our understanding of the cosmos that it won the Nobel Prize in Physics in 2011, and it immediately raised the perplexing question, what is causing this acceleration? The matter and energy we know, including dark matter, can only slow expansion through its gravitational pull, so there must be some other form of energy or property of space that is driving this acceleration. Physicists quickly named it dark energy. But that name is basically an admission of ignorance. It's a fancy way of saying that we have no idea what it really is. We just know that it's there, that it makes up approximately 68% of the entire energy content of the universe, and that it's causing the cosmos to expand ever more rapidly. And here we finally come to the true nature of our cosmic prison, the bubble that Tyson says we can never escape. And I wonder as I explain this, where are you watching from now? What is your city, your country? Comment there because it's fascinating to think that all of us, no matter where we are on this planet, share the same fundamental cosmic prison, and understanding that connects us in a profound way in our collective quest to understand our place in the universe. The accelerating expansion of the universe creates something that cosmologists call a cosmological event horizon. And yes, this term is deliberately chosen to evoke parallels with black hole event horizons because there are profound similarities between them. They emit will never reach us, no matter how long we wait, no matter how many trillions of years the universe continues to exist. Let's be very precise about what this means. Currently, the cosmological event horizon is approximately 16 billion light-years away from us. Any galaxy that is further away than that is moving away so quickly that the light it emits today will never reach us. The space between us and it is expanding faster than light can pass through it. It's like trying to swim against a current that is flowing faster than you can swim. You can try with all your might, but it will still be carried backwards. And this is true even of light, which is the fastest thing allowed by the laws of physics. This means that these distant galaxies are fundamentally inaccessible to us, not just practically inaccessible due to technological limitations, but physically and fundamentally inaccessible due to the very laws that govern space-time. Even if we developed a spacecraft capable of traveling at 99.999% the speed of light, even if we had energy unlimited and unlimited time, yet we could never reach those regions because space is expanding faster than anything, including light, can pass through it. But it gets even more disturbing because the cosmological event horizon is not stationary. It is continually approaching us, With every second that passes, more galaxies cross this boundary and become permanently inaccessible. Currently, something like 20,000 galaxies a day are disappearing beyond our cosmological event horizon forever. Think about this for a moment. Every day that you live, every 24 hours that pass as you go to work, eat from firm, interacts with people. 20,000 entire galaxies, each containing hundreds of billions of stars, each star potentially with planets, each planet potentially with landscapes, phenomena, perhaps even life, are crossing an invisible boundary beyond which we can never reach them, observe them, or even know of their existence. They simply disappear from the accessible universe, like ships sinking beyond a horizon, except that these ships will never return. Ever. Not in 1,000,000 years. Not in 1,000,000,000,000 years. Not in all future eternity of the cosmos. Neil deGrasse Tyson described this situation in a particularly memorable talk he gave a few years ago. He said something that really captures the existential melancholy of this discovery. He noted that we are living in a special epoch of the universe, a window of time where we can still see and study a significant fraction of the cosmos, our distant future descendants. If humanity or some form of intelligence derived from us survived for hundreds of billions or trillions of years, we'll live in a much lonelier, much emptier universe than ours, because most of the galaxies we see today will have disappeared beyond the horizon. The Milky Way and its closest neighbor Andromeda, which incidentally will collide and merge in approximately 4 billion years to form a giant elliptical galaxy that some astronomers jokingly call Lactomeda. These two galaxies, together with the few dozen dwarf galaxies in our gravitationally bound local group, will be all that will be left visible in the night sky. All the other hundreds of billions of galaxies that we see today with our telescopes will have moved so far away that its light will never reach us again. The night skies of our distant descendants will be almost completely black, except for a single island of light, our own merged galaxy, floating in a seemingly infinite and eternally dark void. Tyson then made a profound observation. He said that if intelligent civilizations arose at this distant future time, they would have no way of discovering the expansion of the universe in the way that we have discovered, because there would be no distant receding galaxies to observe. There would be no cosmological redshift to measure. They would look at the cosmos and see only their own galaxy surrounded by eternal darkness, and they could reasonably conclude that the universe consists only of their galaxy, that it has always existed more or less as it is now, that it is eternal and unchanging. They would be fundamentally unable to discover the true nature and history of the cosmos because the evidence would simply no longer be available, would have disappeared beyond the cosmological event horizon. And Tyson asked, what does this tell us about our own situation? What crucial evidence about the nature of the universe may have already disappeared beyond our horizon before we even developed eyes to see? What fundamental aspects of reality are fundamentally unknowable to us, not because of limitations in our intelligence or technology, but simply because the necessary evidence lies beyond the physical limits of what we can observe? This is a question that keeps cosmologists up at night. This idea that there may be deep truths about the nature of reality that are simply inaccessible to us because of the fundamental limits imposed by the physics of our observable universe. And there's more, because not only is the prison getting smaller in terms of how many galaxies we can access, the very information we can get about the universe is being continually degraded by expansion. Think of it this way. When you observe a distant galaxy, you are seeing light that was emitted billions of years ago. That light carries information about what that galaxy was like when it emitted the light, but as that light travels through expanding space, its wavelength is stretched, it is redshifted, and the longer the light travels, the further away the source, the larger it is. This redshift Eventually, the galaxies are so far away and moving away so quickly that the light is redshifted to radio wavelengths, then to even longer wavelengths. And finally, the light is so scattered, so weak, so redshifted to enormous wavelengths that it becomes effectively undetectable. The information it carried is diluted to the point of practical uselessness. But let's pause here because I know your mind must be blown by these revelations about the fundamental limits of our access to the cosmos. And if you are as fascinated as I am by these discoveries about the true nature of our cosmic existence, then please like this video, subscribe to the channel, and turn on notifications because we have so many more mind-blowing scientific revelations in store. There are many things to share with you in the coming weeks, and believe me, what's coming is equal parts disturbing and wonderful. Now let's delve even deeper into the implications of this cosmic prison, because it has an added layer of weirdness that few non-scientists fully appreciate, and that is that the expansion of space doesn't work exactly the same on all scales. Einstein's general relativity, which is our best theory of how gravity works and how space-time behaves, tells us that the expansion of the universe is a property of space itself. But this expansion only dominates on very large scales where the density of matter is relatively uniform. On smaller scales where there are significant concentrations of mass, gravity trumps expansion. This is why you and I are not expanding, why the Earth is not growing, why the solar system remains stable, and why even our entire galaxy and its local group of neighboring galaxies are not breaking apart due to cosmic expansion. The combined gravity of all these objects is strong enough to keep them gravitationally bound, immune to the expansion of space around them. This means that our cosmic prison has an interesting structure. The local group of galaxies to which we belong, including the Milky Way, Andromeda, and a few dozen smaller galaxies, is gravitationally bound and will stay together forever no matter how much the universe expands. These galaxies are our permanent cosmic family, our island of gravitational stability in an ocean of expansion. But beyond the local group, beyond a distance of a few million light-years, expansion dominates. And all those hundreds of billions of other galaxies that we see with our telescopes, all those magnificent structures of stars and cosmic gas and dust, they are all moving away from us inexorably. And due to cosmic acceleration, they will eventually disappear beyond our event horizon. So our final bubble, the region of space that will remain eternally accessible to us, is essentially the local group of galaxies. Everything else will eventually fall out of reach. Let me put this into perspective in a way that perhaps makes the scale of this prison more understandable. The local group is approximately 10 million light-years across and contains perhaps 50 to 60 galaxies. This may seem like an astronomical volume, and in fact it is, but compare it to the current observable universe, which has a diameter of approximately 93 billion light-years and contains something like 200 billion galaxies. We are talking about being confined to a tiny fraction of the cosmos, less than 1/1,000,000% of the current volume of the observable universe, and an even smaller fraction of the total number of galaxies. It's like living on a small island with a few dozen houses, while an entire continent with billions of cities, each with its own culture and history and unique wonders, slowly sinks into the ocean around you, disappearing forever beyond the horizon. And you can do absolutely nothing to stop or even slow down this process. You just sit there on your island, watching the rest of the world disappear, knowing with absolute certainty that you will never be able to visit it, or even know what's going on there. Neil deGrasse Tyson has a particularly evocative way of describing this situation. He often uses the analogy of being on a boat in the ocean, enveloped in dense fog. You can only see so far in all directions before the fog obscures everything. That limit of visibility is your horizon, and you know there must be a lot more ocean beyond what you can see, probably infinitely more, but you can never directly access anything beyond that horizon. And if the fog is getting progressively closer, what you can see is constantly getting smaller. Your accessible reality is shrinking, and this analogy perfectly captures our cosmic situation. Except, instead of fog, it is the accelerating expansion of space itself that is creating a horizon beyond which we cannot see or travel. And that horizon is closing around us tighter and tighter with each passing moment. But there's another layer to this story that we need to explore, because the natural question that arises is, why is dark energy doing this? What is this mysterious force that is tearing the cosmos apart and trapping us in an ever-shrinking bubble of space-time? The honest answer is that we don't know, and this is one of the most humbling and fascinating admissions in modern physics, that approximately 68% of the entire energy content of the universe is composed of something we don't fundamentally understand. We have a few hypotheses, of course. The most popular and mathematically simple one is that dark energy is simply a constant, and cosmological, an inherent energy density of empty space itself. In quantum mechanics, we discover that what we call a vacuum is not actually empty. It is teeming with pairs of virtual particles that constantly arise and annihilate on incredibly small scales of time and space. And these quantum vacuum fluctuations should theoretically have an associated energy density. The problem is that when physicists try to calculate what that energy density should be using quantum field theory, they get a number that is greater than the observed value of dark energy by a factor of approximately 10 to the power of 120. That is a 1 followed by 120 zeros. This is possibly the worst prediction in the history of physics, a discrepancy so absurdly enormous that it clearly indicates that there is something profoundly wrong or incomplete in our understanding, whether of quantum mechanics or of general relativity, or of how these two fundamental theories relate. Other hypotheses propose that dark energy is not constant, but rather a dynamic field that changes over time and space, something physicists call quintessence. But so far, all observations are consistent with a simple cosmological constant. We see no evidence that dark energy is changing. There are also more radical proposals that perhaps there is no dark energy at all, and what we are seeing is actually evidence that Einstein's general relativity is wrong or incomplete on cosmological scales, which we need a modified theory of gravity to explain observations. But these modified gravity theories have their own problems, and so far none of them have worked as well as simply accepting that there is some form of energy we don't understand filling the universe. The unsettling truth is that we are in a situation where we know we are trapped in a contracting cosmic bubble. We know mathematically how and why this is happening in terms of the equations of general relativity, but we don't fundamentally understand the underlying physical cause. It's like knowing you are in a prison cell but having no idea who built the prison or why that it exists. And there are more layers of weirdness to explore, because the cosmological event horizon is not the only boundary that defines our cosmic bubble. There is also something called the particle horizon, which is the boundary beyond which no information or causal signal can reach us from the beginning of the universe. This is different from the event horizon, which is about the future, about what we can never achieve. The particle horizon is about the past, about where information can reach us from, given the limitations of the speed of light and the finite age of the universe. Currently, the particle horizon is approximately 46.5 billion light-years away, and that is the reason why the observable universe has that radius. But there is also a future horizon about what will happen long after today if we wait infinite time, say hundreds of trillions of years in the future. We will eventually see light from objects that are currently beyond our particle horizon. But due to cosmic acceleration, there are regions of space that we will never see, no matter how long we wait, because they are beyond the horizon of events. So we have these multiple horizons defining different aspects of our cosmic bubble, what we can see now, what we can eventually see if we wait, and what we can never see or achieve no matter how much time passes. Now, you may be wondering, what if dark energy changes? What if it starts to weaken or even reverse? Couldn't this change this whole situation? And the answer is yes, absolutely. But here's the problem. All of our observations so far, from 1998, when we discovered acceleration, to the most recent data from missions like the Planck satellite and the Dark Energy Survey, all of these observations are consistent with dark energy being a cosmological constant, meaning it doesn't change. It has the same energy density everywhere, and at all times, if this is correct, then the acceleration will continue forever, and our cosmic bubble will continue to shrink. Inexorably, eventually, in a few tens of billions of years, all galaxies beyond the local group will have disappeared beyond the horizon, and our distant descendants will live in a dark and lonely universe where only one galaxy, the merger of our Milky Way with Andromeda, shines in an eternal void. But there are alternative scenarios that are even more dramatic and disturbing. Some models of dynamic dark energy predict that the acceleration could even increase over time. In a scenario called the Big Rip, dark energy would become as strong as ever. Intuitively, it would begin to tear apart gravitationally bound structures. First, clusters of galaxies would be ripped apart, then individual galaxies, then star systems, then planets, then eventually molecules. Atoms and even atomic nuclei would be ripped apart. The very fabric of space-time would be torn apart in a final cosmic catastrophe. Fortunately, there is no observational evidence that this is happening, but we also cannot rule it out completely. The point is that there is a lot of uncertainty about the ultimate fate of the universe, and so about the ultimate size of our cosmic bubble, but what we know with a high degree of confidence is that, assuming the physics we know is correct, there are fundamental and insurmountable limits on what we can access in the cosmos. Let us now consider the philosophical implications of this discovery, because they are profound and disturbing. Throughout human history, ever since we began to contemplate our place in the cosmos, there has been a tendency to discover that we are less special, less central than we thought. The ancient Greeks believed that the Earth was at the center of everything. Then Copernicus showed that the Earth orbits the Sun, not the other way around. Then we discovered that the Sun is just one ordinary star among hundreds of billions in our galaxy. Then we discovered that our galaxy is just one among hundreds of billions. In the observable universe, every step has been a blow to the human cosmic ego, a realization that we are smaller, less significant than we thought. But the discovery of the cosmological event horizon and our imprisonment in an ever-shrinking bubble of space-time represents something different. It's not about us being less central. It's about there being fundamental limits to knowledge and exploration. No matter how far we advance, no matter what we discover or invent, there will always be vast regions of the universe that are fundamentally inaccessible to us. And these inaccessible regions are constantly growing as more and more galaxies cross the event horizon and disappear forever from our reach. There is something profoundly melancholy in that. This realization that the cosmos is so much bigger and richer than we can ever explore or understand. That there are trillions of galaxies with their own histories, their own planets, potentially their own conscious beings, trying to understand the universe just as we do. And we will never know anything about them because they are beyond our causal horizon, and they are receding faster and faster. Neil deGrasse Tyson often talks about how this discovery should give us a renewed sense of urgency about exploring and understanding as much of the universe as possible while we still can. He argues that we are living in a golden age of cosmology, a brief cosmic moment where we have both the technology necessary to make detailed observations of the deep cosmos and an observable universe still rich and populated with hundreds of billions of galaxies to study. Our distant ancestors in the past did not have the necessary telescopes and detectors. Our distant future descendants will not have the galaxies to observe because they will have disappeared beyond the horizon. Only we, at this particular moment in cosmic history, have both the capacity and the object of study necessary to unlock the deep mysteries of the universe. And if we do not do so now, if we do not take advantage of this window of opportunity, the information may be lost forever. But there is another, even deeper philosophical implication, and that is about the nature of what is real and knowable. Philosophers have long debated questions such as, if something exists but cannot be observed or detected in any way, does it really exist in any meaningful sense? What does it mean to say that something is real if it is fundamentally beyond any possibility of measurement or interaction? These are not just abstract philosophical questions. They have real consequences for how we think about the cosmos. Because we know that beyond our cosmological event horizon there is more universe, we know from observations and theory that the universe does not magically end at the boundary of what we can see. The expansion continues beyond. There are probably billions or trillions or infinite number of galaxies beyond our horizon, cosmic structures as vast and ancient as the ones we see here. But they are in a part of the universe that we will never be able to interact or communicate with in any way, not even in principle. They exist in a physical sense, but not in an operational sense for us. So in what sense can we say that they are part of our universe? Some physicists and philosophers argue that we should define the universe as the region of space-time that is causally connected to us, all within our event horizon, and consider everything beyond that as literally a universe. So different, causally disconnected from ours, part of a multiverse where different regions of space are so separated by expansion that they effectively become distinct realities that can never influence each other. This is a radical conceptual change, rethinking what we mean by universe, going from being everything that exists to being everything that can affect or be affected by us. And there's more, because our cosmic bubble is not just a prison in the sense of limiting where we can go, it also fundamentally limits what we can know about the laws of physics and the nature of reality. Think of it this way. Suppose that in some region of space far beyond our event horizon, physics works differently, perhaps due to some feature of the quantum vacuum that varies from place to place, or perhaps because we live in a much larger universe where different regions went through different histories of phase transitions in the early universe. If these other regions are causally disconnected from us, if no signal from them can ever reach us, then there is no way to detect or measure these differences. For all practical and operational purposes, the only laws of physics that matter are those that operate within our causal bubble. This means that there may be fundamental aspects of physical reality that are simply unknowable to us, not because we lack intelligence or technology, but because the evidence is literally out of reach beyond the causal horizon. Tyson often observes that this should make us a little humble about how much we actually know about the universe. We may have beautiful, mathematically elegant theories about how everything works, and these theories can make incredibly accurate predictions about everything we can observe within our bubble. But that doesn't necessarily mean that these theories capture the entirety of reality. There may be much more out there that we simply cannot access, and some of our most cherished theories may turn out to be just local approximations that work well in our region of the cosmos, but which are not universally true. The word universe is perhaps a misnomer. Perhaps we should call it ours. Verse, our local portion of the cosmos, recognizing that there may be other verses, other causally disconnected regions with their own histories and possibly their own laws. So what can we do with all this? How should we respond emotionally and intellectually to the discovery that we are trapped in a contracting cosmic bubble from which we can never escape. Tyson suggests a few perspectives that might help process this disturbing information. First, he notes that even if we are confined to the local group of galaxies, this is still an incredibly vast territory to explore. We are talking about 50 to 60 galaxies collectively containing trillions of stars and presumably trillions of planets. If we ever develop technology for interstellar or even intergalactic travel, there is enough within our bubble to keep humanity busy, exploring for billions and billions of years. We won't run out of places to go anytime soon. On the timescale of for any conceivable civilization, the local group is more than enough. The fact that there is more universe beyond that we cannot reach is melancholy philosophically, but does not practically limit what we can do or where we can go in any foreseeable future. Second, Tyson often emphasizes that the very discovery that we are trapped in this way is in itself an extraordinary intellectual triumph. The fact that hairless apes on a small rocky planet orbiting an ordinary star were able to unlock the secrets of cosmic expansion, discover dark energy, calculate the position and properties of the cosmological event horizon, predict the fate of billions of years of the cosmos, all using only our intelligence, mathematics, and ingenious scientific instruments, is absolutely extraordinary. We are the universe becoming aware of itself. Even though the answers we discover reveal limits to what we can know and do, the process of discovery itself has immense value. Third, this discovery gives us a unique perspective on our moment in cosmic history. As I mentioned before, we are living in a special era where we can still see and study a significant fraction of the cosmos before it disappears beyond the horizon. This is no coincidence or special privilege. It is simply when we happen to have evolved intelligence and developed technology, but it still gives us a unique responsibility and opportunity if we care about knowledge and understanding. If we value understanding our place, in the cosmos, so we have a duty to take advantage of this window of opportunity while it exists, to make the observations, conduct the experiments, develop the theories that can help us understand as much as possible about the universe while it is still accessible. Each future generation will have less cosmos to study, so it is up to us in the current era to do as much as we can. And finally, there is a perspective that Tyson shares that I find particularly beautiful and comforting. He notes that even though we are trapped in our cosmic bubble, even though we can never reach or communicate with regions of the universe beyond our event horizon, the simple fact that they exist, that there is more cosmos out there, more complexity, more structure, more history, possibly more life and consciousness trying to understand the universe just as we do. Even if we can never directly interact with them, there is something comforting in knowing that we are not alone in the broadest sense, that the cosmos is so much bigger and richer than our little bubble, that there is a vastness out there that continues beyond what we can see or touch. And in a poetic and philosophical sense, we are all part of the same universe, all subject to the same fundamental laws of physics, all made of the same elementary particles created in the Big Bang, all sharing the same cosmic history of expansion and evolution since that first hot, dense moment 13.8 billion years ago. And even though we are causally separated now due to accelerated expansion, there is still a deep and fundamental connection. We are all children of the same universe, all participants in the same cosmic experiment of existence and consciousness. Now, what do you think of all this? Do you think there is some way to escape this cosmic prison that physicists have not yet considered? Do you feel claustrophobic knowing that we are confined to the local group of galaxies? Or do you feel inspired by the immense territory we still have to explore even within our bubble? Comment your thoughts, because I really love reading what you think about these deep issues. And who knows, your ideas might even inspire the channel's next video. We are all part of this journey of discovery together, and your perspective matters. Returning to science, there is one aspect of this story that we have not yet fully explored, and that is the relationship between our cosmic bubble and other deep questions in physics and cosmology. For example, this discovery has fascinating implications for the so-called measurement problem in quantum mechanics, and for questions about the role of consciousness in the universe. Some physicists argue that the fact that we are confined to a finite causal bubble means that the universe we can measure and observe is fundamentally finite, even though the universe as a whole may be infinite. And this has consequences interesting for how we think about quantum probabilities and wave function collapse. I'm not going to go into all the technical details here because that would deserve a whole video by itself. But the basic idea is that if the observable universe is finite, then there are only a finite number of possible quantum states within it. And this can help resolve some strange paradoxes that arise when we try to apply quantum mechanics to infinite universes. There are also deep connections with information theory and the so-called holographic principle, which is one of the strangest and most fascinating ideas in modern theoretical physics. Originally developed by Gerard 't Hooft and Leonard Susskind, inspired by Stephen Hawking's work on black hole entropy, the holographic principle suggests that all the information contained in a volume of space can be thought of as encoded at the boundary of that volume, like a hologram where a three-dimensional image is encoded on a two-dimensional surface. Applying this to our bubble cosmic, some physicists speculate that all information about everything that happens within our cosmological event horizon could in principle be encoded on the surface of that horizon. This raises deep and disturbing questions about the nature of reality. Do we live in a kind of holographic projection? Could it be that the three dimensions of space that we experience are somehow less fundamental than we think? These are questions on the frontier of current theoretical physics, and there is no consensus on the answers. But the important point is that the discovery that we are trapped in a cosmic bubble is not just an astronomical curiosity. It has profound implications and ramifications across multiple areas of fundamental physics. And there's more, because our cosmic prison also has implications for one of the biggest unanswered questions in science. Are we alone in the universe, or are there other forms of intelligent life out there? The famous Fermi paradox asks, is the universe so vast and ancient? If there are billions and billions of stars and planets, then where are all the aliens? Why don't we see obvious signs of advanced civilizations? There are many proposed answers to this paradox, but the discovery of the cosmological event horizon adds a new layer, because it means that there may be advanced civilizations in galaxies other than our local group, but due to the accelerating expansion of the universe, we and they are in separate causal bubbles. We may be trying to communicate, but our signals never reach each other because the space between us is expanding faster than light can pass through. It is like two castaways in lifeboats being carried by currents in opposite directions in the ocean. They may be waving to each other, shouting, sending signals, but if the current is strong enough, they will never reach each other, and eventually they will disappear beyond each other's horizon. Our cosmic bubble may be full of other intelligent civilizations, each trapped in their own bubble, each looking out into the cosmos and wondering if they are alone. And the cruel and ironic answer may be that, no, we are not alone. There are others out there, but we are so separated by the expanse of space that we can never make contact. We can never share knowledge. We can never even know of each other's existence. This is possibly the most profound and existentially disturbing form of cosmic loneliness, not being truly alone, but being so isolated that the difference is practically irrelevant. Tyson sometimes speculates about this in his talks, imagining civilizations in distant galaxies that, like us, have discovered accelerating expansion and realize that they are trapped in their own cosmic bubbles, each civilization looking up at the sky and seeing hundreds of billions of galaxies. But knowing that most of them are already beyond causal reach, have already crossed the event horizon and is receding forever, and perhaps some of these civilizations are sending signals, trying to make contact, transmitting radio waves or laser pulses or some other form of communication that we have not yet discovered. But these signals are traveling through a space that is expanding faster than they can traverse, so the signals dilute, weaken, scatter, until eventually they become indistinguishable from the cosmic background noise, and the civilizations that sent them disappear beyond the horizon. Their messages not surrendered, their efforts to make contact thwarted not by lack of desire or ability, but by the very laws of the universe that ensure that certain regions of space can never communicate no matter how hard they try. But let's bring this back to a more personal and immediate scale, because I think it's important to not just understand these discoveries abstractly, but to really feel and internalize what they mean to us as individual humans living our lives on this little planet. When you look up at the night sky now, after understanding all this about our cosmic bubble and the horizons that surround us, what you see must be fundamentally different. Every point of light you see is a star or galaxy within our observable bubble. Every photon that enters your eyes, it has traveled through expanding space for thousands or millions or billions of years to reach it, carrying information about distant places and times. But beyond what you can see, beyond the faintest stars visible even with our most powerful telescopes, there is much more universe that is permanently hidden from us, not by technological limitations but by fundamental limitations of physics. There are galaxies out there right now, with their own stars and planets and perhaps life, that are moving away from us so quickly that the light they emit today will never reach us. They exist, but are fundamentally and eternally invisible to us. And with each passing day, more and more of these galaxies cross the invisible boundary of our event horizon and join the ranks of the permanently inaccessible. This may sound depressing, and I admit there is a real melancholy to it, a sense of loss about all the cosmic wonders we will never see, all the places we will never visit, all the phenomena we will never study because they are out of reach beyond our bubble. But I also think there is something profoundly beautiful and inspiring about this discovery, because it shows us that we are part of something much bigger than ourselves, much bigger than even our galaxy or our local group or even our observable universe. We are part of a cosmos that extends far beyond what we can see or measure, a cosmos that can be infinite in extent and complexity. And the fact that there are limits to what we can know and achieve does not diminish the value and significance of what we can do within our bubble. On the contrary, perhaps makes it more precious, more urgent, more important that we take advantage of this unique opportunity we have to explore and understand as much as possible while we can. And thinking about this makes me reflect on parallels in our own lives. We are all confined in certain ways. We all have horizons and limits to what we can experience and know. You are limited to living in one place at a time, to knowing a finite number of people, to reading a finite number of books, to visiting a finite number of places in your life. No matter how hard you try, no matter how long you live, there will always be infinitely more possible human experiences that you will not have, infinitely more knowledge that you will not have. You will learn infinitely more beauty and wonder in the world that you will not witness, but that does not make your life meaningless or your experiences worthless. On the contrary, finiteness and limitation are part of what makes life precious, what makes every moment and every choice meaningful. And perhaps it is the same with our cosmic prison. The fact that there are limits to what we can know and do in the cosmos does not make our efforts of exploration and discovery meaningless. It makes them more meaningful because we are doing the best we can with the opportunities and resources we have. We are pushing against the limits of the possible. We are extending the reach of human knowledge as far as physics allows. And there is one last aspect of this story that I want to mention before I conclude, and that is about the very distant future of the universe and the ultimate fate of our cosmic bubble. If dark energy really is a cosmological constant, if the acceleration continues forever as all current evidence suggests, then the long-term future of the cosmos is quite bleak in a sense. As we have discussed, eventually all the galaxies beyond the local group will disappear beyond the horizon. The night sky will be dark except for our own merged galaxy Lactomeda. But that's just the beginning, because the expansion continues forever. Gradually, even within our galaxy, the stars will begin to go out as they exhaust their nuclear fuel. New stars will stop forming as interstellar gas is gradually consumed or expelled. Eventually, in perhaps 100 trillion years, all the stars will have died. The universe will be populated by cold stellar remnants, white dwarfs, neutron stars, black holes, lonely planets drifting in the dark, but even these objects do not last forever. Stephen Hawking discovered that black holes are not actually black. They emit a weak quantum radiation called Hawking radiation. And over unimaginably long periods of time, much longer than the current age of the universe, this radiation causes the black holes to slowly evaporate. A black hole with the mass of the Sun would take approximately 10 to the 67 years to completely evaporate. A supermassive black hole at the center of a galaxy would take even longer, perhaps 10 to the 100 years. These numbers are so absurdly large that it is difficult until we understand them. But the point is that eventually, given enough time, even black holes disappear. And at the ultimate end of the cosmos, perhaps 10 to the 100 or 10 to the 120 years in the future, the universe will be cold and dark and almost completely empty, consisting mainly of widely scattered individual photons and occasional elementary particles. All the complexity, all the structure, all the stars and galaxies and planets and life that once existed will be long forgotten, dissolved by the relentless expansion and march inexorable entropy. Physicists call this the heat death of the universe, and it's a pretty depressing picture of ultimate cosmic fate. But even here, there are interesting nuances, because some physicists speculate that even in this cold, dying universe, there may be interesting phenomena going on. Occasional quantum fluctuations on unimaginably long timescales may briefly create organized structures, what physicists call Boltzmann brains, conscious entities that arise spontaneously from the random fluctuations of the quantum vacuum by sheer statistical luck. And although this sounds like crazy science fiction, it is actually a legitimate consequence of trying to apply quantum mechanics to truly timescales. If you wait literally infinite time, even incredibly improbable events will eventually happen, including the random formation of complex structures and even conscious entities. So maybe the universe is never truly dead. Maybe there will always be some spark of complexity and consciousness emerging here and there in the depths of cosmic time. But these are speculations on the most distant frontier. Much of theoretical physics, no one really knows what happens in the truly distant future. We are extrapolating our current theories far beyond the regime where they were tested. And this brings us back to the central point, the discovery that we are trapped in a cosmic bubble, that there are fundamental and insurmountable limits to what we can know and achieve in the universe. This is one of the most profound and disturbing revelations of modern science, as significant as the discovery that the Earth is not the center of the universe, or that time is not absolute but relative. Neil deGrasse Tyson is absolutely right to draw attention to this and to emphasize its implications, because it fundamentally changes how we should think about our place in the cosmos. He reveals that the universe is much bigger, much richer, much stranger than our local bubble suggests, but also that there will always be much that is beyond our reach, not because of temporary limitations of technology, but because of permanent limitations of fundamental physics. And I think there is something both humbling and inspiring about that. Humbling because it reminds us that we are small, finite, limited in a cosmos that is vastly larger than us, but inspiring because the simple fact that we have managed to discover and understand these limitations, which hairless monkeys on a small planet have done, unveiling the secrets of cosmic expansion and calculating the limits of the knowable. This is extraordinary. It demonstrates the incredible power of the human mind and the scientific method. So if you've made it this far with me on this deep journey through the outer reaches of the cosmos and the nature of our cosmic prison, if your mind is exploding with all these revelations about cosmological event horizons and dark energy and the distant future of the universe, then please like this video. Subscribe to the channel and turn on notifications because we have so much more fascinating scientific exploration ahead of us. And believe me, the mysteries of the cosmos are infinite, even if our ability to reach them is not. And I want to be here with you, discovering as much as possible about this incredible universe while we still can. Because, as Neil deGrasse Tyson reminds us, we are living in a special era, a window of opportunity where we can still see and study a large fraction of the cosmos before it disappears beyond our horizon forever. And let me close with a final reflection that I find particularly beautiful. When the ancient Greek philosophers looked up at the sky, they saw the stars fixed in crystalline spheres. They thought the cosmos was small, finite, limited, and in some ways they were right about there being limits, but wrong about everything else. The cosmos is not small. It is vast beyond comprehension, but rather, there are fundamental limits to what we can achieve. Not crystal walls, but space-time horizons. Not small, but incredibly distant. Not imposed by capricious gods, but by the very laws of physics that govern reality. And there is something poetically appropriate about this, that at the end of all our scientific exploration, after expanding our knowledge of the cosmos from a small sphere of nearby stars to hundreds of billions of galaxies spread across tens of billions of light years, after discovering the expansion of the universe and the Big Bang and dark energy and all these extraordinary phenomena, we still come to a conclusion that echoes that ancient intuition that there are boundaries to the cosmos. Only now we understand those boundaries very much deeper, not as physical walls, but as fundamental causal boundaries written into the very fabric of space-time. And there is a strange beauty in this discovery that yes, we are trapped in a cosmic bubble. But it is a bubble so vast, so rich, so full of wonder and mystery that we have barely begun to explore it. And even if we can never get out, even if there is always more beyond that we cannot reach, there is still infinity to discover within the limits of our causal horizon. There are still trillions of stars to study, billions of planets to explore, countless physical phenomena to understand, and above all, there is still the ongoing journey of discovery, the process of pushing against the limits of knowledge, of asking deep questions about the nature of reality and working to answer them. And this process, this search for understanding, is what makes us human at our best. It is what gives meaning and purpose to our existence in this vast cosmos. And no event horizon, however fundamental and insurmountable, can take that away from us. The prison may be real, but within it, there is infinite freedom to explore, to question, wonder, and grow. And in the end, maybe that's what really matters. Not the size of our bubble, but what we do inside it. Not how many galaxies we can reach, but how deeply we can understand those that are within our reach. Not how long the universe will last, but how fully we live and explore in the time we have. Because all of us, every human being, every conscious civilization, if there are others, we are all trapped in some sense, limited by physics, biology, mortality. But within those limits, there are extraordinary possibilities, and it is up to us, individually and collectively, to make the most of these possibilities, to explore our corner of the cosmos with curiosity and wonder, to seek knowledge and understanding wherever they take us, and to marvel at the extraordinary fact that we are the universe, contemplating itself, molecules so complexly organized that they have become conscious and can ask questions about their own origin and destiny, and that, in the end, is far more wonderful and meaningful than any size cosmic prison could ever diminish.